All right, buckle up everyone, because today we're diving headfirst into the world of machine learning system design. We'll be using the book Machine Learning System Design by Valerii Babushkin and Arseny Kravchenko as our trusty guide.
Sounds complex, right?
Well, you might think it's just for, the hardcore tech wizards,
Yeah.
but believe me, this stuff is way more relevant to our everyday lives than you might realize.
Oh, absolutely. I mean, think about it, whether it's that algorithm suggesting your next Netflix binge or the AI behind self-driving cars, these systems are already shaping our world.
Exactly. And this book really helps demystify how they work.
It does a fantastic job of taking these complex concepts and breaking them down into understandable chunks. So no PhD in computer science required.
Which is great news for us.
Yeah.
So get ready to tackle some pretty big questions today, like why is data the lifeblood of machine learning? And what happens when an AI learns the wrong thing?
Ooh, good one.
And how do we make sure these AI systems are good enough without breaking the bank trying to make them perfect?
These are all super relevant questions, and it's surprisingly relatable too. I think of designing a good machine learning system like planning a road trip. You need a clear destination in mind, a reliable map to get you there, a car that won't break down, and a plan for handling those unexpected detours along the way.
Okay, I love that analogy.
And this book is kind of like our roadmap for this deep dive.
Perfect. So let's start with the basics. What exactly is machine learning system design? The book describes it as this fascinating blend of machine learning knowledge, software engineering, and even a touch of product management.
It's really interesting how interdisciplinary this field is. A great ML system designer has to be a bit of a jack of all trades. Part researcher, figuring out the best algorithms for the job, part engineer, building the system itself, and part visionary, thinking about how people will actually use it.
It's almost like this field needs people who can wear multiple hats at the same time.
Exactly.
Now, the book really stresses that understanding the problem you're trying to solve is absolutely critical. And they illustrate this with a really good example. They talk about a sales VP who requests an AI system to rank sales leads. Sounds straightforward enough, right?
Yeah, on the surface it does.
But the authors highlight how if you just jump into building a solution without really understanding the nuances, like what makes a good lead versus a bad lead,
Yeah.
you're basically setting yourself up for failure.
Right. It's like imagine you're baking a cake, but you don't even know what kind of cake you want or what ingredients you have on hand. You're going to end up with a big mess.
A recipe for disaster. Speaking of recipes, the book also makes a strong case for having a solid design document, even for small projects.
Totally agree. They even debunk the myth that design documents are only for those massive corporations. It's like a blueprint for our machine learning house. You wouldn't start building without a blueprint, right? And you definitely wouldn't start adding extra rooms without updating the plans. A good design document helps you spot those potential blind spots early on.
Saves you a lot of headaches down the road.
Absolutely.
Okay, so we've got our blueprint. Now let's talk about the building blocks. Data. The book calls data sets the lifeblood of any machine learning system.
And they're right. Data is like the fuel that powers the whole machine learning engine.
And just like with cars, the type and quality of the fuel really matters. You wouldn't put diesel in a gasoline engine, right?
Exactly. You need the right kind of data for your machine learning model to work properly. And that means having it in the right format and making sure it's good quality.
The book talks about all sorts of data sources, from the unique data that companies like Google have access to the more readily available open source data sets.
Right. But it's not just about having data, it's about having the right data for the specific problem you're trying to solve. And that often involves labeling it correctly.
Labeling.
Yeah, like imagine you're training a model to recognize different types of clothing.
Okay, got it.
But you have two shirts that are almost identical, but one's labeled as formal and the other is casual. That's going to confuse the heck out of the model.
Right.
So techniques like active learning and crowdsourcing can help with the labeling process, but you got to have rigorous quality control. You need to make sure everything is consistent and accurate.
Now, imagine we've prepped our data, we're ready to unleash our machine learning model. It's almost like we're teaching it to see patterns and make predictions.
It is. It's pretty amazing.
But how do we actually guide its learning process? I mean, how do we tell it what's right and what's wrong?
That's where loss functions come in. They basically act as this feedback mechanism, telling the model how well it's doing. Think of it this way. You're trying to calculate the average income of people in a room, But then suddenly Bill Gates walks in.
Okay, yeah.
Your average is going to be completely skewed, right? Loss functions help the model adjust its understanding and optimize for the outcome you want.
So it's like they're helping the AI avoid making those really obvious mistakes.
Yeah. Exactly. But you also have to be careful about choosing the right metrics to evaluate its performance.
Because sometimes the model might learn the wrong lesson.
Oh, for sure. And the book has this really interesting cautionary tale about a debt collection model that did amazingly well in testing, but totally flopped in the real world.
Really?
Yeah, and it failed because of the subtle difference in how debtor was defined in the training data versus how it was defined in the real world.
Oh, wow.
And that highlights just how important it is to make sure your data, your metrics, and your real-world application are all aligned. Even a small mismatch can have huge consequences.
So basically, we need to make sure our AI isn't learning bad habits or getting stuck in a rut. And speaking of bad habits, the book mentions this concept called overfitting.
Overfitting, yeah. That's when the model learns the training data too well and fails to generalize to new information.
So it's like a student who memorizes the answers for a test, but doesn't actually understand the concepts.
Exactly. They might ace that specific test, but they won't be able to apply their knowledge to anything new.
Right, so it's all about finding that sweet spot, right? We don't want our AI to be a one-trick pony.
Exactly. And of course, you have the opposite problem too, which is underfitting. That's when the model doesn't learn enough from the data.
Okay, so finding that balance is key.
It is. And one way to help strike that balance is through error analysis.
Error analysis.
Yeah.
That's where we basically dive into the model's mistakes and figure out why it's making them, right?
Yep. The book talks about different techniques for doing this, including residual analysis.
Right, which is basically examining the leftovers of a problem.
Exactly. You're looking for patterns in those differences between what the model predicted and what actually happened. It can help uncover hidden biases or highlight areas that need improvement.
Fascinating. And then there's this other technique called adversarial validation, which sounds a bit intense.
It's like having a devil's advocate for your model. You're constantly challenging it with tricky examples to make sure it's truly robust and can handle surprises.
So it's all about making sure our AI is ready for the real world. We've talked about data, algorithms, and even potential pitfalls. But what happens once our model is trained and ready to be unleashed? That's where deployment comes in, right?
Exactly. Deployment is all about taking that carefully trained model and integrating it into a live system where it can make predictions based on real-world data.
So it's like we're finally opening the doors of our AI pizzeria and letting the customers in.
That's a great way to put it. But as the book cautions, it's not as simple as just flipping a switch. There are a lot of important decisions to make during deployment.
Like what? Give us a sneak peek of what's to come in part 2 of this deep dive.
All right, well, we'll be talking about things like choosing the right infrastructure, setting up monitoring systems, and making sure your system is reliable enough to handle real-world data.
Sounds like we've got a lot to cover.
We do, but don't worry, it'll be a delicious journey. Welcome back to our deep dive into the world of machine learning system design. Last time, we talked about the importance of data, right? Like having the right kind of data and making sure it's labeled properly.
We did, and we even touched on those tricky pitfalls like overfitting.
Right, where our model becomes a bit of a one-trick pony, memorizing the training data instead of learning the underlying patterns. But before we send our AI out into the wild, there's more groundwork to cover, right? It's not just about building a model, it's about building a whole system that works seamlessly.
So where do we go from here? What's step 1?
Well, the book recommends starting with a baseline solution.
A baseline solution? Sounds kind of basic.
It might sound basic, but it's super important. It's like laying the foundation of a house. You wouldn't start building the fancy roof before you have a solid base, right?
Okay, I see what you mean.
Mhm.
So in the machine learning world, what does a baseline solution actually look like?
It could be something as simple as a constant predictor. Basically, it just outputs a fixed value no matter what the input is.
So for our pizza AI, that would be like saying every pizza needs exactly 10 pepperoni slices, regardless of the size or what the customer actually wants.
Exactly. Not very sophisticated, obviously, but it gives you a starting point, something to measure your progress against.
Okay, so it's like a benchmark. We see how well our simple solution performs, and then we can start building more complex models from there.
Exactly. You can try things like simple rule-based models or even linear regressions and see how much improvement you get with each step.
So we're gradually adding more complexity, like building a staircase one step at a time.
That's a great way to think about it.
But the book also warns against getting too carried away with complexity, right? They talk about this accuracy-effort trade-off.
Yeah, that's a crucial point. As your models get more complex, they need more data, more computing power, and just more time to develop. And sometimes that extra little bit of accuracy might not be worth the extra effort and cost.
So it's finding that sweet spot. It's like adding 20 toppings to your pizza. It might not actually taste better, and it'll definitely be harder to manage.
Exactly. You've got to be pragmatic about what level of accuracy is actually necessary for your specific problem.
Right, because we don't want to over-engineer our pizza AI and end up with a system that's too complex to maintain.
Absolutely. So once you've established your baseline, you have a sense of how complex your model needs to be, you've chosen your algorithms, it's time to actually train the model.
This is where the magic happens, right?
Mm.
Where we feed our AI all that data and it starts to learn.
It is. But as the book emphasizes, training a machine learning model isn't just a matter of hitting go and hoping for the best.
There's more to it than that.
Oh, yeah. It's a process that needs careful management and structure. And that's where training pipelines come in.
Okay, hit me with another analogy. What's a training pipeline?
All right, imagine a well-run kitchen. You wouldn't just throw all your ingredients in a bowl and expect a delicious meal to magically appear, right?
Definitely not. There's a whole process involved.
Exactly. There's a specific order of operations, prepping the ingredients, measuring them out, combining them in the right way, cooking them at the correct temperature. A training pipeline is like that recipe for your machine learning model.
So it breaks the whole training process down into manageable steps.
Exactly. It defines the flow of data from its raw state all the way to the final trained model.
So that could include steps like cleaning the data, pre-processing it, splitting it into training and validation sets, feeding it to the algorithm, evaluating the model.
It's all part of the process, and then potentially retraining it if you need to.
Right, because sometimes our pizza AI might need a little extra practice before it's ready to make those perfect pies.
Exactly. And just like a good recipe, your training pipeline needs to be reproducible.
Reproducible.
Yeah. You should be able to run it multiple times with the same data and get the same results. It's about consistency.
Makes sense. You know, you mentioned inference pipelines earlier. Is that the same thing as a training pipeline?
That's a great question. They are related, but they serve different purposes. A training pipeline is all about, well, training the model. It's where you teach your AI how to do its thing.
Right. So in our pizza analogy, that's like teaching our pizza AI how to actually bake a perfect pizza.
Exactly. But an inference pipeline is all about using that trained model to make predictions in the real world.
So it's like once our pizza AI has graduated from pizza school, the inference pipeline is the actual pizza shop where it's putting its skills to the test.
Perfect analogy. And just like running a successful pizza shop, optimizing your inference pipeline is crucial. Things like latency, throughput, and scalability become super important.
Okay, break those down for me. What do those fancy terms actually mean?
All right, latency is basically how quickly your system can respond to a request.
So for our pizza AI, that's how fast it can bake a pizza, because no one wants to wait an hour for their order.
Exactly. And throughput is all about how much your system can handle at once. How many pizzas can our AI churn out per hour?
We got to keep up with demand.
Right. And scalability is about being able to handle even more orders as your pizza business grows.
World pizza domination. Here we come.
That's the spirit. And the book actually goes into detail about different techniques for optimizing these things, like caching, for instance.
Caching, is that like keeping those pre-made pizza crusts handy?
Exactly. It can save you a lot of time if you've got those common orders ready to go. But let's go back to our training pipeline for a second. Once our model is trained, how do we actually assess how well it's doing? How do we know if it's truly ready for prime time? That's where error analysis comes in. It's like carefully inspecting each pizza for flaws, making sure everything is cooked to perfection.
So we're looking for those burnt crusts and undercooked toppings.
Exactly. We need to understand where the model is making mistakes and why. And remember, residual analysis, that's still a useful tool here. It helps us identify patterns in the errors.
Right, those leftovers from the prediction process.
Exactly. And don't forget about adversarial validation. That can be really helpful for uncovering hidden biases in the model.
Okay, so if our pizza AI is getting a perfect score because it's only ever seen pepperoni pieces, adversarial validation would be like throwing some pineapple on there just to see how it reacts.
Exactly. We need to make sure it can handle the unexpected.
Make sure it's not just memorizing patterns from a limited data set. Okay, so we've got our training pipeline, we've optimized our inference pipeline, and we've thoroughly analyzed all the errors. Now it's time for the grand opening, right? Time to deploy our pizza AI.
It is, but, and the book really stresses this, deployment is not as simple as just flipping a switch. There's a lot to consider.
Like what? What are some of the things we need to think about when we're deploying our pizza AI?
Well, for starters, you need to choose the right infrastructure to host your model.
Infrastructure, you mean like servers and stuff?
Exactly. Is it going to live on a powerful server in the cloud, or will it be embedded directly into a smart oven?
Ah, so the choice of infrastructure depends on the complexity of our pizza AI and how much pizza we're planning to make.
Exactly. And you also need to think about setting up systems to monitor your AI's performance once it's out in the real world.
Right. We can't just set it and forget it. We need to make sure it's not serving up pizzas with the wrong toppings.
Exactly. You need monitoring systems to track things like accuracy, the speed of the predictions, any errors that pop up.
So it's like having a security camera in our pizzeria, making sure everything is running smoothly.
It is. And you also need alerting systems, so you get notified immediately if any problems come up. That way you can fix them before they impact too many customers.
So we've got the infrastructure, the monitoring, the alerts. What else do we need to think about?
Well, you need to make sure your system can handle real-world data.
What do you mean?
The data your AI encounters in the real world, it might be a bit messier than the nice, clean data it was trained on.
Right. Real-world data is unpredictable. You never know what kind of crazy pizza toppings people are going to come up with.
Exactly. And your system also needs to be able to handle the volume of orders. Imagine if your system crashes on Super Bowl Sunday because it can't handle all the orders coming in.
That'd be a disaster.
It would. That's where scalability comes in. Being able to easily expand your system's capacity as needed.
Got it. So it's not just about building a smart AI. It's about building a smart system that can handle the real world.
You've hit the nail on the head. But we're not done yet. There's one crucial element we haven't talked about. The humans.
Ah, right. We can't forget about the people who are actually ordering and making the pizzas.
Exactly. We need to think carefully about how humans will interact with our pizza AI, both from the customer's perspective and the employee's perspective.
So how do we make our system human-friendly? I mean, we don't want our customers getting frustrated trying to order a pizza or our employees struggling to use the AI.
Well, that's where API design comes in. API stands for Application Programming Interface.
API. Sounds complicated.
It's not as bad as it sounds. Think of it as a bridge between your pizza AI and the humans interacting with it.
So if a customer wants extra cheese and pepperoni, the API translates that request into instructions that our pizza AI can understand.
Exactly. A well-designed API makes the interaction seamless and intuitive. Customers can easily customize their orders, track their deliveries, all that good stuff.
And it makes life easier for the employees too, right?
Absolutely, they can manage inventory, track orders, troubleshoot any problems, all through the API.
So it's like having a friendly and efficient waiter taking orders and communicating them to the kitchen staff.
That's a great way to put it. And the book really emphasizes that APIs should be simple, predictable, and well-documented.
Right, because we don't want people scratching their heads trying to figure out how to use our system.
Exactly. It should be easy and enjoyable for everyone.
So it's not just about building a smart AI, it's about building a smart system that integrates seamlessly with the human world.
You got it.
And we're back for the final slice of our deep dive into machine learning system design. We've come a long way, haven't we? From those basic building blocks all the way to deploying our very own pizza-making AI.
It's been quite a journey. Training pipelines, inference optimization, error analysis, we've covered a lot of ground.
But as we've learned, deploying our AI is really just the beginning, right? It's like opening the doors of our pizzeria for the first time. Now we need to make sure everything runs smoothly, our customers are happy, and hopefully avoid any kitchen nightmares.
Exactly. And that's where monitoring and reliability becomes super important. We need to keep a close eye on our system, make sure everything's working as it should, and catch those potential problems before they turn into major meltdowns.
So imagine we're in the control room of our pizzeria, staring at this big dashboard with all sorts of graphs and metrics about our pizza AI. What are we looking for? What are the warning signs that tell us something might be off?
One of the most crucial things to monitor is data quality. Remember how we talked about how important good data is for machine learning?
Right, garbage in, garbage out.
Exactly. If the data flowing into our system is bad, the predictions coming out will be bad too. It's like trying to bake a pizza with rotten tomatoes. You're not going to get a very tasty result.
So if our pizza AI suddenly starts adding pineapple to every pizza, we might want to check if someone messed up the ingredient database.
Precisely. We need to be on the lookout for things like missing data, unexpected values, sudden shifts in the data distribution. The book calls this data drift.
Data drift.
Yeah, it's basically when the data changes over time. It can happen for all sorts of reasons. Maybe a new supplier starts sending us square pepperoni instead of round, or suddenly there's a huge spike in demand for vegan cheese.
Our pizza AI might be totally thrown off by those changes if it hasn't been trained to handle them.
Exactly. And that means we need to be able to detect those changes and adapt our system accordingly. Sometimes that means retraining the model with new data, adjusting those pre-processed steps, or even tweaking the model's parameters.
But what if it's not just the data that's changing, but like the very definition of what makes a good pizza? Imagine suddenly everyone wants gluten-free cauliflower crust. That would be a real challenge for our pizza AI, right?
That's a great point. That's what we call concept drift. It's when the patterns our AI has learned no longer hold true, even if the data itself seems fine.
So our pizza AI was trained to make those classic Neapolitan-style pizzas, but now everyone's demanding deep dish Chicago style.
Exactly. And dealing with concept drift often involves retraining the model on new data that reflects that shifted concept. You might even need to develop a whole new model specifically designed for this new reality.
It's like our pizza AI needs to go back to pizza school and learn some new techniques.
Exactly. But let's not forget about monitoring the model itself, not just the data it's being fed.
Right. We need to make sure our pizza AI isn't secretly developing a taste for pineapple when we're not looking. How do we actually monitor the quality of the model itself?
We keep a close eye on those metrics that tell us how well the model is performing, things like accuracy, precision, recall. If we see a sudden drop in accuracy or a spike in errors, it could be a sign that the model is degrading or that there's something wrong with the inference pipeline.
So it's like noticing that our pizza AI is suddenly burning more pizzas than usual. We need to investigate and figure out if it's a problem with the AI itself, or maybe the oven isn't working properly.
Exactly. And just like with data drift and concept drift, addressing model degradation might involve retraining, tweaking the inference pipeline, or even developing a new model if the issues can't be fixed.
Okay, so we're constantly monitoring the data, keeping an eye on the model, looking for any signs of trouble. But what happens when something inevitably goes wrong? Does our whole pizza operation come to a screeching halt?
That's where reliability comes in. A well-designed system should be robust and resilient, able to handle those failures gracefully and recover quickly.
So it's about having a backup plan, right?
Exactly. The book talks about strategies like redundancy, for example.
Redundancy. So like having a backup oven in case the main one breaks down.
Exactly. You anticipate potential points of failure, and you have those backup systems in place to minimize the disruption.
Makes sense.
All right.
But what about those situations where you can't just switch to a backup? Like, what if we run out of dough or the delivery driver gets stuck in traffic?
That's where fallback mechanisms come in. It's like having a stash of frozen pizzas we can bake if we run out of fresh dough.
Or having a backup delivery service on standby.
Exactly. You got to have those contingency plans.
I'm really loving these analogies. It makes this whole process so much clearer.
I'm glad they're helpful. But the key takeaway here is that you need to have those robust monitoring, alerting, and incident management systems in place. That way you can identify problems quickly, notify the right people, and resolve those issues as fast as possible.
So we've built this amazing pizza-making AI. We've deployed it in our state-of-the-art pizzeria. We've got all these monitoring and reliability systems in place. But there's one crucial element we haven't talked about yet. The humans.
You're absolutely right. No ML system exists in a vacuum. We need to think carefully about how humans are going to interact with our pizza AI, both from the customer's perspective and the employee's perspective.
So how do we design our system to be human-friendly? We don't want customers struggling to place their orders or employees wrestling with the AI to get things done.
Well, this is where API design becomes crucial. API stands for Application Programming Interface, and it basically acts as a bridge between our pizza AI and those humans interacting with it.
Okay, so the API is like a translator. If a customer wants to order a pizza with extra cheese and pepperoni, the API takes that request and turns it into instructions our pizza AI can understand.
Exactly. And a well-designed API makes that interaction seamless and intuitive. Customers can easily customize their orders, track their deliveries, you name it.
And on the employee side, the API lets them manage the inventory, track orders, troubleshoot any problems that might come up.
It's like having a friendly and efficient waiter taking orders and communicating them to the kitchen staff.
Everyone's on the same page. The pizzas are flowing smoothly from order to delivery.
Exactly. And the book stresses how important it is to make those APIs simple, predictable, and well documented. You don't want people getting frustrated trying to use your system, right? A
Mhm.
good API should make the experience smooth and enjoyable for everyone involved.
So it's not just about building a smart AI, it's about building a smart system that plays well with humans.
That's a great way to put it. And that brings us to the final piece of the puzzle, maintenance.
Maintenance.
Yeah, just like any complex machine, our pizza AI needs regular checkups, updates, maybe even the occasional repair to keep it running smoothly.
So it's not just set it and forget it.
Definitely not. You need to track those changes, test new features, be ready to roll back to a previous version if you need to, and you've got to monitor the system's performance over time, look for opportunities to optimize and enhance its capabilities.
So we're always making sure our pizza oven is calibrated correctly, experimenting with new recipes to keep our customers coming back for more, and constantly trying to improve our whole pizza making process.
Exactly. Machine learning system design is an ongoing journey.
Wow, this deep dive has been incredibly insightful. I feel like we've covered so much ground.
It's been my pleasure. We've explored the fascinating world of data, algorithms, pipelines, and I think we've shown that building a successful machine learning system takes more than just technical skills.
Right. It's about understanding the problem, planning carefully, knowing that it's an iterative process, and remembering that humans are a big part of the equation.
Couldn't have said it better myself.
A huge thank you to our expert for leading us on this incredible journey through the world of machine learning system design. And to our listeners, if you're hungry for more, we highly recommend checking out the book, Machine Learning System Design.
It's packed with valuable insights and practical advice for anyone who wants to build those intelligent systems that can make a real difference in the world.
And remember, whether you're building a pizza-making AI or tackling some other complex problem, the principles of good system design, they're universal. Think critically, plan strategically, and don't forget about the human element.
Great advice.
Well, that's a wrap for this deep dive. Thanks for joining us. We'll be back next time with another fascinating exploration, so stay tuned.